Oh, hey. Morning. I shall return. Hello. Yeah. Put your name in the chat, please. do it this way. Change my background to a blur instead of. Okay. Oh, man. It's freaking cold. Put that back up.
Forecast for Wednesday night supposed to be almost freezing, and then weekend, yeah, that's gonna be a trip.
Yeah. I don't know about around y'all, but around me, people are already making runs on the grocery store.
Yeah, I'm about to head out after this class, professor, grab a few things.
Stock up on the TP. Where are we time wise? Okay. Oh, I know what I'm doing here now. There we go. How y'all doing? Did y'all put names in the chat if you could? This cooler weather makes my cats go nuts. We got one cat that fights the other two, and or she growls and hisses at them. Let me put it that way. She'll attack them, and they just kind of leave me alone. Anyway. Yeah. Oh, let me see. Be sure your name is put in chat. Let's see here. Never absent. About 2 minutes before time. I don't do well waiting. Never have. Let's see here.
Hello, sir.
Yes.
Yes, I've been having trouble accessing like the homework. I was trying to figure out how do I access that one again because like I don't know. It's like going through the textbook. It doesn't seem to be working.
Second here. Okay. I just for pull up. Okay, in Canvas, click on the Alamo books and you go launch the courseware. Is that what you do?
Yeah, but it takes me somewhere else.
Yeah, it takes you over to here, which is on the Pearson website. And I know you you already have an account in there, so this screen should show up, and you just click open My Lab, and it'll take you to it. Only yours will show up different because you're a student.
Okay, it was just taking me somewhere else beforehand.
Okay.
Thank you.
All right. Stop that share. All right. Let me see. Let me see. Let me see. Oh, I know what that noise was. Okay. Let me close that down. All right. So who else? Okay. We're just about, well, no, we're up to 18. We should have 25, including me. This up. That up. All right. Are any other questions about the homework or anything? Okay, I'm not seeing any. So I'm going to go ahead and get started. Please be sure and be in My Lab, and please be sure and be doing work. Okay. You should be well on your way of finishing the first homework if you haven't done that already, and have started the second homework. And we should finish the section 6.2 today. And oh, that's not the screen I wanted to have up. We were looking at this the other day, and this is kind of where we wound up. And when we're talking, when they talk about finding the exact values of the 6 trig functions, what I like to do is how we find them. Okay, we have 0 degrees, 30 degrees, 45, and then the 60, and then the 90, and the next one is 120, and then 135, and then the 150, 180, 210, 225, what's the next one? 240, and then 270 degrees, and then 300, and then 315, then 330 degrees, and then the 360 degrees. 360 degrees takes us back to full circle. The quadrantial angles are at 0 radians, pi over 2, pi, 3 pi over 2, and 2 pi. Quadrantial angles are 0, 90, 180, 270, and 360. And then we have the 45-degree angles, which is 45, 135, 225, and 315. So those are pi over 4. And the first one is 1 pi over 4. This would be 2 pi over 4. And then we have 3 pi over 4. And this would be 4 pi over 4. So now we have 5 pi over 4. And this one would be 6 pi over 4. And then so the next one is going to be 7 pi over 4. And this one is 8 pi over 4, 2 pi. And then we have the 30 and 60 degree angles. So 30 is pi over 6. 60 is pi thirds. 120 is 2 pi thirds. And 150 is 5 pi over 6. And then the next one's going to be 7 pi over 6, and then 4 pi over 3, and then 5 pi over 3, followed by 11 pi over 6. Yeah, there's some tricks to finding these. Sometimes it's just easier to memorize them than learning all the little tricks. But what's really important is the first quadrant angles, because the ordered pairs, the coordinates that go with them, follow a pretty rigid pattern. At 0 degrees, the x is 1 and the y is 0. At 90 degrees, we had done these the other day. And at 180, it's -1 and 0. And at 270, it's 0, -1. And at 360, we're back to full circle. Now, these other angles in here, there's a pattern to how we write them. Each one is going to be a fraction that has a denominator of 2. Okay. And the rest of these are going to be built upon the first quadrant. So the first quadrant is paramount. Well, once you know the first quadrant, the others, there's several different patterns here to finding those others. And this, I'm going to show you most of them. And so one way to put these numbers in is you just start counting. You start with the sign, you start with the Y values. And so you start counting 1, 2, 3, and then you move over to the X's and you count up 1, 2, 3, and then you take the square root of all the numerators. So the square root of 3, the square root of 1 is 1, square root of 2, square root of 2, square root of 1 is 1, square root of 3. Boom, we have them. We didn't have to figure out what they were. We just have to recognize the pattern and take the square roots. Okay. Now, the next 3 to fill in, you're just going to have these same ordered pairs. They're just going to be in the reverse order. So it's going to be 1/3 square root of 3 over 2. I mean 1/2 square root of 3 over 2. Okay. But in the second quadrant, the X values are negative because now these three here are in the second quadrant where the X's are negative and the Y's are positive, right? Because they're over here. Right. The first set were in the first quadrant where they're both positive. And so the 45-degree angles, they're gonna be square root of 2 over 2 for both numbers. It's just one of them might be negative or they both might be negative. Right. Since we're in the first quadrant, the X's are gonna the X's are gonna be negative and the Y's are positive. So we have, so I'm writing them down the reverse ordered pair that they have them there. And so this last one's going to be the negative square root of 3 over 2 and 1/2. And now we're going to do the same thing again. I'm going to look at these 3 and reverse their order again. So I'm going to follow this order again. So it's going to be square root of 3 over 2, 1/2, square root of 2 over 2, square root of 2 over 2, and I'm leaving enough room between them because I'm going to do something there. Square root of, no, that's going to be 1/2. And it's 1/2 square root of 3 over 2, right? I either look at it as I'm reversing this order here again, or I'm just copying this order down again. So the first and third quadrant, yeah, because these here are in the third quadrant, those ordered pairs are in the same order, except now, because we're in the third quadrant down here, both X and Y are negative. So both of these will be negative. Okay, so both the X and the Y values are negative. So it's a negative square root of 3 over 2, negative 1/2, negative square root of 2, negative square root of 2, negative 1/2, negative square root of 3 over 2. And for this last one, yes, we reverse this order or we take the second quadrant order and use those. And so, and then the fourth quadrant now, the X's are positive and the Y's are negative. So this will be a positive 1/2, a negative square root of 3 over 2. And this one's going to be a positive square root of 2 over 2, a negative square root of 2 over 2 for the Y value. And for 330 degrees or 11 pi over 6, the X value is going to be a negative, I mean, not negative, it's going to be square root of 3/2, square root of 3 over 2, and a negative 1/2. So all you really need to memorize is these numbers here in the first quadrant. And no, cat, no, don't. You're going to knock something down and I'm going to be upset. Yeah, you got 2 cats in competition for my attention, and part of that is climbing up my desk and onto my stuff up here. Very frustrating. Okay. So I'm going to come back. Well, actually, what I'm going to do is I'm going to pull up this one, and we have this here, and I have all the angles already all filled in. That one's supposed to be that way. Please don't do that, cat. I don't want you up there. Okay. So, no, damn it. Okay. So we had this one was square root of 3 over 2 1/2, and this one was square root of 2 over 2 square root of 2 over 2, and this one was 1/2 square root of 3 over 2, and this was 0 1, and this was 1 0. Now, what we have here is a bunch of symmetries, and we'll go through the slides, and the slides will show us these symmetries as well. And this one's kind of crowded. Okay, so I'm going to write those back in again. Square root of 3 over 2, Thomas. All right, now I'm going to look at the symmetry of the picture of the circle. All right, these are on the same horizontal line, so their y values are going to be the same, square root of 3 over 2, but the x values are going to be opposites. Where this went a positive 1/2 this way, this one's going a negative 1/2 this way, so this is a negative 1/2. The in absolute value terms, the numbers are the same. It's just which one's, there's just one of them now negative. And so it's going to follow the same pattern all the way down. Well, these are the what are the 60-degree angles. And so we have something with the 60-degree angles. Those are the ones that have pi thirds. So pi thirds, 2 pi thirds, 4 pi thirds, 5 pi thirds. Okay, so those, the x and y are in the same order. And the 1/2 and the square root of 3 over 2 are in the same order. It's just one of them is negative, or they're both negative, or the other one's negative. So down here, they're both going to be negative, and it's still going to be negative 1/2, and then a negative square root of 3 over 2. And then this one over here, the x value becomes positive, but the y value stays negative, and it's still 1/2 and the square root of 3 over 2. And so, yeah, so we have that sense of symmetry there, where all I need to know is this one, and then these follow the same pattern. It's just one of them's negative, or they're both negative. Okay. And then the 45-degree angles follow the same kind of, follow the exact same deal. So here we have this. Why is it right? Oh, I see why. So we have this. So this will be square root of 2 over 2 and square root of 2. Square root of 2 over 2, but the x value is negative there. And then we come down here to this 45-degree angle, and this is, they're both going to be negative. So square root of 2 over 2, square root of 2 over 2, and they're both negative. And then we come over to this quadrant, and the ordered pairs are in the same order. So, and it's, well, the x and y are always going to be square root of 2 over 2. It just depends upon whether it's negative or not. And then the, whoops, that completes the symmetry all the way around. And then the 30-degree angles, which is 30 or pi over 6, and 150 or 5 pi over 6, and then 210 or 7 pi over 6, and 330 or 11 pi over 6. They're all still going to have 3 halves. I mean, 3 pi, square root of 3 over 2, 1/2 as their x and y's. Is just the signs depend upon which quadrant they're in. And so we go over to this quadrant, and it's going to be negative square root of 3 over 2, positive 1/2. And then we come down to the third quadrant, and they're both negative. So it's a negative square root of 3 over 2, 1/2. And then we come over to the fourth quadrant, where the x is positive and the y is negative. So it's square root of 3 over 2 and a negative 1/2. And then that brings us back to the first quadrant. Now this is going to be for 180 and 0. It's just the x value is going to be negative over here, and the y value is 0. And for these 2 points, this one up here and this one down here, the y value, the x value is 0 in both cases, but the y value, this one up here is positive 1, and this one down here is negative 1. So you got that kind of symmetry going on, where one of them, the signs change. So when you do the symmetry around, the signs change appropriately. That's another way of looking at it. Again, are you really concerned about, or what are these numbers here? And then you can find those others simply by changing the appropriate sign. Or you can go through the mathematics and the algebra to find those numbers, which is something most people don't want to do. But I play with numbers all the time. And that's how I always used to build it. A very good friend of mine over at SAC, he used to have these wonderful conversations. And sometimes the conversations covered how we covered the material. And he told me that he didn't worry about showing how to do it mathematically. He showed this method. And I like it. I mean, it's quick and easy. And as long as you remember what you're doing, boom, they're done.
And will this work for essentially every single unit circle that will
Yes.
come across? Okay.
For these angles,
Okay.
for these, and these are key angles. So we use those angles a lot.
Okay. Thank you so much.
So yeah, we with this, the textbook, with the textbook starts showing this symmetry here first. The 45-degree angles. I call them the 45-degree angles because they're 45 degrees off the quadrantals. Okay, so and then the 60-degree angles, because they're 60 degrees off of the x-axis. It's 60 degrees this way, it's 60 degrees that way, it's 60 degrees this way, it's 60 degrees this way. So the reference angle for those angles is 60 degrees. So the only difference between those coordinates will be where the negative signs are. Okay. And same thing is true with the 30-degree angles. And I call them the 30-degree angles because that's the reference angle for them. The reference angle is over here. And so this is 30 degrees, this is 30 degrees, this is 30 degrees, and this is 30 degrees. That's what we call reference angles, is how many degrees off of the horizontal axis is it? And then you have your X and Y in the first quadrant, and then you just switch the signs appropriately for the quadrant you're in. So anyway, so the exact values of the 6 trig functions, well, we wrote them all down already, right? So 45 degrees is this pair of numbers. Square root of 2 over 2, square root of 2 over 2. And let me pull up a sheet of paper. And so we're dealing with the square root of 2 over 2 and the square root of 2 over 2 for our X and Y. So the sine of pi force, or the sine of 45 degrees, because they're the same angle, is going to be, that's the Y value, and Y equals the square root of 2 over 2. The cosine of pi over 4 is the X value, which is the square root of 2 over 2. Tangent, the tangent of pi over 4 is Y over X. And since Y and X are the same value, this just equals 1. So this is sine of pi over 4. Okay, which equals Y, which equals that. Now, cosecant of pi over 4 is the reciprocal of the sine. The sine is, and so that's going to be 1 over the square root of 2 over 2, which is 2 over the square root of 2. We're just flipping the fraction in the denominator. And so I multiply numerator and denominator by the square root of 2 so I can rationalize my denominator. My denominator becomes 2. My numerator is 2 times the square root of 2. Those go to 1, so that just leaves me the square root of 2. Secant of pi over 4, or 45 degrees, is the reciprocal of cosine. Well, the reciprocal of cosine is going to equal the reciprocal of sine in this case because they're the same value. So I'm going to get the square root of 2 again. I just don't have to write out that I did all those calculations because I already did them. Actually, what I should do is say I'm doing this. I'm doing 1 divided by the square root of 2 over 2, which we already calculated to be the square root of 2. And then cotangent's the easiest one to do of the reciprocals, because cotangent of pi over 4 is 1 over the tangent of pi over 4, which is 1 over 1, which is 1. Yeah, One is its own reciprocal. 1 and -1 are their own reciprocals, and they're the only two numbers that is true for. And I notice. Okay. Okay, 1 second. All right. Where was I? So since we already have those things written down, yeah, and the 45-degree angles, they're going to be the sine and cosine of the 45-degree angles are going to be the same values, except some might be negative because of the quadrants. Oh, and that. Before I continue on, another thing I wanted to talk about here is like on with this thing. Here in the first quadrant, and I only talk about the sine, cosine, and tangent because the reciprocal functions have the same signs. But in the first quadrant, they're all positive. All the trig functions are positive. In the second quadrant, only the cosine and secant are positive. All the others are negative. No, not cosine, it's sine. Sorry. Sine and cosecant are positive up there. And in the third quadrant, it's the tangent and cotangent that are positive. All the others are negative, right? Because both x and y are negative here. So that means the sine and cosine and the reciprocals will be negative. But since tangent and cotangent are fractions involving sine and cosine, you get a positive. And in the fourth quadrant, only the cosine and the secant are positive down here because only the x's are positive, the y's are negative, which makes all the other trig functions negative. Okay. So depending upon which quadrant we wind up in and what they're asking for, we know which ones are going to be positive and which ones are going to be negative, simply because of which quadrant we're going to end up in. All right, let me go back to the okay. So now, yeah, finding those exact values and yeah, this is finding it mathematically. What they did here was finding it mathematically, what those values are going to be, because the x and y are the same, then x squared, and because it's a unit circle, because it's a circle and it's a unit circle with the radius is 1, so that's going to be the formula for a circle with the center at 0 is x squared plus y squared equals r squared. And since the radius is 1 and 1 squared is 1, so that's how we get x squared plus y squared equals 1. And since x and y are the same value at that point, then we're adding x squared to x squared, which is 2x squared, and then solving for x, we get x is the square root of 2 over 2, and y is square root of 2 over 2. So that's how we find those values using the mathematics involved, the geometry. And then you build those angles, the what do you call it? The trig values based on those numbers, which is what we did. And so the cosine of 45 is the square root of 2 over 2. Let me do a new page. Square root of 2 over 2. And the sine of 270, well, that's a quadrantial angle, and the sine at 270 is a -1. And so that's going to be the negative square root of 2 over 2. The cotangent of pi over 4, well, the cotangent at the 45-degree angles and the tangent are going to be the same value, but this is in the first quadrant, so it's a +1. And the cosine of 3 pi over 2, well, 3 pi over 2 is a 270-degree angle, and the x value there is 0. So this is just 1. 1 minus 0 is 1. And the third case here, cosecant is 1 over. Yeah, and didn't we do that? The cosecant is the square root of 2. And so we square cosecant, we square 2. Sometimes my equal signs look like 2's. We square the square root of 2, which is 2. And then we're going to subtract the secant of pi. The secant of pi is the y value at pi, which is 0. Wait a minute, secant. No, that's 1 over cosine, right? So 1 over cosine, cosine at that place is a -1. So it's going to be 2 minus a -1, which is 2 plus 1, which is 3. Okay. So knowing those values helps you find these values, and these are exact. Whenever they say exact values, you don't punch it into the calculator. You leave the square root symbols in there unless they go away naturally, like it does here. All right. All right, and then we already did that. Or, well, the 6 trig functions of 60 look just like the 6 trig functions of 30. Is just they're moved around a little bit, because the sine of 30 equals the cosine of 60. Cat staring down at me. I'm getting paranoid now. All right. So we have And this forms a 30-60 white right triangle. Yeah. I used to, back when I took my first, well, it was actually my second college algebra, calculus 1 class, on just about every test, you would see this. This is 1, this is 2, this is a square root of 3, and this is a 60, 30, 30, 60, 90 triangle. And then you would see this, which is a 45, 45, 90. So it's an isosceles right triangle where each leg is 1 and the hypotenuse is a square root of 2. And I would build up my trig table based on these. Just knowing which quadrant I would wind up in. So here for 60 degrees, the sine is opposite over hypotenuse. So that's yeah. No, I did this wrong. So I usually have them. I'm going. I normally set it up where the 30-degree angle is down here. That's why. I was going off of muscle memory here. So the square root of 3/2 is the sine here, which is the cosine of up here, which is the adjacent side over the hypotenuse, square root of 3/2. If two angles are complementary, that means they add up to 90. Then the sine of one plus is equal to the cosine of the other, and vice versa. So yeah, these are, and that we're going to come across that rule a little later in this class. So we're just using those points rather than we're not building those up. And so it's just using the same pattern of the sine of theta equals y and the cosine of theta equals x, and then the tangent of theta equals y over x, and the cosecant of theta equals 1 over y, and the secant of theta is 1 over x, which is 1 over cosine, and then the cotangent of theta is x over y, which is the reciprocal. So these are the basic trig functions and their reciprocal functions. So this is an important table of the trig functions to know. All right, and since x equals cosine of theta and y equals the sine of theta, then our x and y ordered pair can be written as the cosine of theta, comma, the sine of theta. And to tell you the truth, this is how when we start talking about unit circle, that's how I think of the x and y. I think of them as cosine theta, y theta, sine theta. Okay, so I'm not going to go through all of these because we already did them, and it's just setting up the ratios appropriately. And here's a little table there for those. Now, over here, what we have is we're looking at this rain gutter. And so we have 3 angles we want to consider, right? We want to consider a 30-degree angle, a 45-degree angle, and a 60-degree angle. Okay, and we have a formula that can determine this area in here. Okay. And the greater the area, the more volume the gutter can handle. So we want to maximize this volume, this area, so it will maximize our volume based on these 3 angles. Okay, so we have the formula. The area based on theta is going to be 16 sine of theta. And I'm going to put that inside parentheses because that's what we're doing. We're going to multiply 16 times the sine of theta. And then we're going to multiply that by taking the cosine of theta and adding 1 to it. Okay. That's what this formula is telling us. And so we're going to find the area based on the 30-degree angle. So we do 16 times the sine of 30 degrees. And we're going to multiply that by the cosine of 30 degrees plus 1. Well, what's the sine of 30? So we just did that, didn't we? So you look on the unit circle, what is that y
Is
value?
it 1/2?
1/2, 1/2. So this is 16 times 1/2 or 8. And then what's cosine of 30?
Square root of 3/2.
So now we have the square root of 3/2 plus 1 being multiplied by 8. With 8 times the square root of 3/2 is 4 times the square root of 3, and 8 times 1 is 8. So this is what you would punch into the calculator, and you would round it to 2 decimal places, I think, is what they do. Okay, which is what they did here. So this is approximately 14.93 square inches. They write out square inches, I do inches squared. Same, it's just different notation, means the exact same thing. Oh, geez. And then they do it the 45-degree angle. Well, area of 45 degrees. Well, this is 16 times the sine of 45 times the cosine of 45 plus 1. Well, sine and cosine of 45 is the exact same value. So we have 16 times the square root of 2/2 times the square root of 2/2 plus 1. So this gives me 8 square roots of 2 times the square root of 2/2 plus 1. You multiply in by 8 square roots of 2, and you wind up with square root of 2 times square root of 2 is 2, and 2 divided by 2 is 1. So that's going to be 8 times 1, which is 8. And then 8 times 8 square roots of 2 times 1 is 8 square roots of 2. And so this is what you type into your calculator. And they got 19.31 square inches. So having 45 degrees, you get a bigger area than 30 degrees. And so now the next one is doing it with 60 degrees. So 16, the sine of 60 times the cosine of 60 plus 1. Oh, geez. Yeah. So the sine of 60 is what?
Square root 3/2.
Square root of 3/2. So 16 times the square root of 3/2, which ends up being 8 square roots of 3 times, and the cosine of 60. Oops. Cosine of 60, anyone?
The cosine of 60 is 1/2.
1/2. And 1/2 plus 1 is 3/2. 3/2 of 8 is 12. Because 8 divided by 2 is 4, and 4 times 3 is 8, is 12. And so that gives me 12 square roots of 3, and we type that into the calculator. And it's not going ahead. I know why. And so we get 20.78 square inches, or inches squared. And so the one that maximizes the area is a 60-degree angle. So we would go with a 60-degree angle. All right. Any questions there? So we deal with the exact, but if they're asking for a decimal answer, then if they're asking for an exact answer, and these were the exact answers here with the appropriate units put beside it. But when measuring stuff, this doesn't do, so we have to approximate the answer. Okay. So if they were asking for, if they're just asking for what they're doing here, you need to round it to 2 decimal places or 3 decimal places or wherever. You can just start with this right here and just type that into the calculator. Making sure you use parentheses appropriately, because you want to add that 1 to the cosine of 30 before you multiply it by this product. Okay. Now, the next couple of slides are just talking about looking at this symmetry here that I already talked about. All right. So they all have square root of 2/2, square root of 2/2 in their ordered pairs. It's just sometimes it's negative, sometimes they're both negative, and sometimes only one of them are negative. So, and then we just look to see where we wind up. Okay, or which of these 45-degree angles are we going to wind up on? And so each one of these is a 45-degree angle. It's just It's just which quadrant are we in? We know what the X and Y values are. We just need to determine which quadrant it's in so we can determine which one's negative and which ones are positive. All right. 5 pi over 4 is in the third quadrant. So the X is negative and the Y is negative. So that means the sign is negative. All right. With cosine of 135, that's in the third quadrant. So that means the cosine is negative because the sign is negative, is positive there, but the cosine is negative. Cotangent of 315. 315 is in the fourth quadrant. And so cotangent's going to be negative there because only cosine is positive. Cosine and secant are the only ones that are positive in the fourth quadrant. And so we go to our chart and we look at what that is. Cosine of negative pi over 4. Well, cosine of negative pi over 4, that's the same terminal side as 315 degrees. And they're both in the fourth quadrant. So those two are going to have, well, the cotangent's negative, but the cosine's going to be positive in that quadrant. So that's just going to be square root of 2 over 2. And sine, the cotangent's a -1. And the sine is going to be, this is 11 pi over 4. So you're going around the circle once, and then you go another 3 pi over 4. And so you wind up in the second quadrant, and that's a negative square root of 2 over 2. So it's just looking at where you wind up. Okay. And so we're finding the cosine of that. It's going to be negative. Yeah. So that's x over y. So that comes out to a -1. And it corresponds. All right. And here they're showing the other symmetries I showed with the 30 and 60 degree angles, the pi over 6 and pi over 3. And so finding these exact values, again, is again looking at the unit circle and finding out where you're at. So all right. So negative pi over 3 is the same as 5 pi over 3, which is in the fourth quadrant. So the sign is negative down there. Where 5 pi over 3 is in the that's the same angle. Yeah, as a -60 or -3 pi over 3. So tangent's negative down there. And cosine of 8 pi over 3, 8 pi over 3 means you're going around the unit circle once and ended up at 2 pi over 3, which is the second quadrant, and cosine's negative over there. And this is just using the calculator. The TI calculator has your sine and your cosine and your tangent. And then if you push the second button, and then that's when you have the cosecant and the secant and the cotangent. So you hit and you just have to make sure that you're in the proper mode, whether your calculator is using radians or degrees. You always double check, because you can't always be sure you remember what you last put in there. And so you'll get decimal numbers here, and they want you to round them to the second decimal place. And so on letter B, you hit second cosine, so it'll show up secant on your screen, and then you just type in the 21. Well, if you and as I said, scientific calculators or the graphing calculators are what you need for this course, and they will have all the trig functions. You do a shift or you do a second, and it'll do the reciprocal. So the secant came out to 1.07 when it's rounded. And then you have to change it from degrees to radians to do the last problem, which is the tangent to pi over 14, because pi over 14 is in radians. Okay, if it has pi in the measure, it's in radians. If it doesn't, or if it's degrees, it'll have the degree symbol. If it's in radians, but it's in the decimal form of radians, that means they approximated pi. Then it'll either tell you that it's in that the angle is in radians, or it definitely won't have the degree symbol. Now, if the circle is not the unit circle, so R is not 1, so then we're dealing with a circle whose formula is x squared plus y squared equals r squared. Right, so I always deal in the first quadrant. So we have this situation here where this is R, and this is on the circle, and this is the y coordinate, and this is the x coordinate, right? And this is our angle theta. And so the sine of theta is going to equal the opposite side over the hypotenuse, y over r. Well, that's just the same as what we were talking about with the unit circle. If r is 1, then that's just y, correct? And so the same thing happens with cosine. We have x over the hypotenuse, so that's going to be x over r. And the tangent is opposite over adjacent, so the tangent is going to be y over x again. It didn't change from unit circle to this, to a circle with a radius of r. And the reciprocal functions, the cosecant is a reciprocal of sine, so that's going to be r over y. And the secant is going to be the reciprocal of cosine, which is going to be r over x. And then cotangent is the reciprocal of tangent, with is x over y. All right. So this is actually the only one you really need to know about. But if we go back to talking about the ordered pairs, these ordered pairs here, x equals, well, we have cosine theta equals x over r, or r cosine theta equals x, and we have sine theta equals y over r, or multiplying both sides by r, we get r sine theta equals y. So now my ordered pairs on every single point on this circle is r cosine x comma r sine x, or theta, I should say, theta, not x. I'm thinking ahead here. Okay. And when we go back and look at what I said about the x and y can be written as cosine theta y sine theta on the unit circle, well, that's just 1 times cosine. The radius is 1 times cosine, 1 times sine. It's the same thing. It's just a special case of this. It's just a special case of this. Any questions? Okay. So we're going to use this chart here to calculate. All right, so we have, let me draw it over here. We have 1, 2, 3, 4, 1, 2, 3. So this is that point they're talking about. This is the point 4, -3. So that means this y equals a -3, x equals 4. And this distance here is the radius. And we need to find out what that is. Well, because it's on a circle that is centered on 0, 0, then it's going to be x squared plus y squared equals r squared, which is, so that means 4 squared plus a -3 being squared is going to equal r squared. So 4 squared is 16, -3 squared is a +9, and that equals r squared. So we have 25 equals r squared. Taking the square root of both sides, we get 5 equals r. We want the positive square root because we're talking about a length of the radius. So length is always positive. When we're talking length, the sign only denotes direction. So this is 3 units long. It's just the direction is in the negative. Okay. Oops. So now I can find all 6 of these angles because I have the 3 numbers I need to use. Y is 4. So we start with the sine of theta. Y is 4, R is 5, so that's 4 over 5. With cosine, the Y is negative 3, right? So that's negative 3 over 5. I'm sorry. So the X is 4, so that's going to be 4 over R, which is 4 over 5. And then the tangent is the Y value over the X value. So that's a negative 3/4. Cosecant is a reciprocal of sine. So that's going to be a negative 5 over 3. The reciprocal secant is the reciprocal of cosine. And the reciprocal of 4/5 is 5/4. And cotangent is the reciprocal of tangent. And the reciprocal of negative 3/4 is a negative 4/3. The hardest part about this was finding the radius, which wasn't all that difficult in this case. And they go about finding the X and the R the same way I had done. And then they just plug the numbers in appropriately, like I had done. Any questions on that? Okay, and that was the end of section 6.2. And now we're going to move on to section 6.3. We're going to talk about properties of trigonomic functions. Now, trigonomic functions are different than we talk about the trig functions. Okay. These are functions involving the trigs functions. Okay. So why isn't it? I see why. Okay, it's still not doing what I want it to do. So we're going to determine the domain and range of the trig functions, determine the period of a trigonomic function, and we're going to determine the signs of the trigonomic functions in a given quadrant. Well, we already did that. And find the values of trig functions using fundamental identities, and find exact values of trigonomic functions of an angle given one of the functions and the quadrant of the angle. It's a mouthful. And use even odd properties to find exact values. All right, even odd nature. If a function is even, then it has certain properties. And one of the properties is that f of x, f of negative x equals f of x. So it doesn't matter what the sign of x is. If it's an even function, you'll get the same y value. So if x is 2 or -2, you'll get the same y value. Think of x squared. I square 2 and I square -2, I get the exact same y value. All right. And another property is here is that they are symmetric with respect, there's a C in there, to the y axis. So think of x squared, right? Its symmetry is around the y axis. Okay, where the y axis acts as a mirror. And so that's for even functions. If it's an odd function, then we have the situation where f of -x equals the negative of f of x. So the f of a number will equal the negative of the f of its opposite. So f of 3 will equal the negative of f of -3. Or most people think of it as f of -3 will equal the negative of f of 3. So if you change on the sign of the number you're putting in, then you're going to change the sign of your outcome. Okay, that's all that is saying. And so now the symmetry, it does have symmetry. It is symmetric with respect, I keep forgetting the C, respect to the origin. Another way of thinking about symmetry with respect to the origin, you have rotational symmetry of 180 degrees. So if you rotate it 180 degrees, the graph will line up perfectly with itself. So, and there are other ways of thinking about that. So I got ahead of myself here. All right, so here we have the trig functions. But if we're not using it as where we're using the angle as our domain, the angle is the domain, and the value I get is the range. So what numbers I put in for x, I put in for theta is my domain. Well, what numbers can I put in? All right, what I did in my previous class today. No, I didn't do that. I went here. So I can do 1 to 360 degrees, and can I keep going past 360? Think about it. Can I go past 360 degrees? For the trig functions, can I talk about an angle that is greater than 360 degrees?
I think so.
Yeah, we've worked problems where they
Yeah,
were more
I
than
thought I saw a
360.
450-degree angle one.
Yeah. So I can go around the circle. I can keep going around the circle. I can go around the circle. How many times can I go around the circle?
As many times as you want.
Right. So the largest number here is going to be a positive infinity. So I can go to positive infinity. Can I go in a negative direction?
Yes.
Yeah, I go in the negative direction and I can do the same thing. I can keep going around and around and around until I wind up at the angle I'm talking about. So I can keep going around and around. So I can go to negative infinity. And so the domain for sine and cosine will be all real numbers. Because sine and cosine give me a real number back. There's no number I can't use. In sine or cosine. Now with tangent and the reciprocal functions, we do have some restrictions. Right? Because tangent up here on the unit circle, this is 0, 1. Tangent doesn't exist at pi over 2 or 90 degrees. And tangent does not exist down here either. At 270 degrees or 3 pi over 2. Or the multiples, because I can go around several times and then wind up here. That still won't give me a value because it's undefined. And so we have to eliminate 90 degrees and pi over 2, or their multiples. Well, it's odd multiples. Even multiples wind you up on 0 and on 0, 360, or pi 180. So it's odd multiples, odd integer multiples. It's important we throw in the word integer. So the domain is all real numbers except odd multiple integers of pi over 2 or 90 degrees. Same thing with secant, because secant up here is secant is 1 over x. And if I can't put x in the denominator, if I can't put x in the denominator, I can't use that number. Well, x is 0. I can't put 0 in the denominator, so I can't use it. Same thing with the tangent. That's why we can't use tangent or secant at pi over 2 or the odd multiples. The odd multiples start with 1 times 2, 1 times pi over 2, 3 times pi over 2, which is the 270, 5 times pi over 2, which brings you back up here, 7 pi, 7 times pi over 2 brings you back down here. So you keep bouncing back and forth between these two. Doesn't work. And same thing, yeah. So tangent and secant have the same domain. So guess what? That means cotangent and cosecant are going to have the same domain. Okay. And that deals with the integer multiples of 180 or pi. And yeah, the integers, -3, -2, -1, 0, 1, 2, 3. They go in both directions. So any multiple of 180 degrees or pi will either have you wind up here at pi or at 0 or 0 degrees. So you either wind up here or you wind up there. 2 times pi takes you here. 4 times pi takes you here. 8 times pi takes you here. So the even multiple brings you over here, where the odd multiple brings you over here. So and neither one of them works because the x value, because the y value is 0, and for cosecant and cotangent, you're dividing by the y value. So when the y value is 0, you can't use it. Now the ranges, yeah, this is, I want y'all to think about this. The range is the y values. So I'm going to add another layer here. And so the y values go from -1 here up to and I'm just saying it right now, aren't I? So this is -1 down here, and this is +1 here. And all the y values are between those two, right? When you start punching those numbers into the calculator, square root of 2 over 2, it's going to be less than 1. Square root of 3 over 2, it's going to be less than 1. ½ is less than 1. -1/2 is greater than -1. So it's going to be here. So all the y values wind up being between -1 and 1 for sine and cosine. Does that make sense?
Can you just reiterate that one more time, please?
When you take the sine or cosine of any angle, that number you get will either be from -1 to +1. Because when you think about this point here, which is 1/2 square root of 3 over 2, both of those are less than 1. Right? So as the angle approaches 90 degrees, the y values over here, the y values here are going to be approaching 1. Once you hit 90 degrees, it is at 1, and then the y values start going down again, because as the angle gets larger, that means the y values start coming back down again until you come down here. Once you come down to over here to 180, the y value is 0. But once you get off of 0 going down, now the y values get negative. And they keep getting more and more negative until that angle approach gets to 270 degrees, and then it's at 0. Then it's at -1. And once the angle gets a little bit larger than the 0, I mean, then 270, then the y values start going back towards 0 again. And so the y values, which is the sine values for that angle, go from -1 to +1. And the cosine of the angles go from -1 to +1. And that's what they're talking about here.
Thank you.
All right. Now for cosecant, I talk about cosecant first. Cosecant is the reciprocal. So there's a reciprocal of all these numbers in here are going to be larger than 1. Or less than -1. So if the number is positive and you take the reciprocal of a fraction less than 1, a positive fraction less than 1, you get a positive number greater than 1 because you're switching your numerator and denominator. So now the bigger number's on top. Here you get all proper fractions, positive and negative proper fractions, and the reciprocal of a proper fraction is an improper fraction. And so an improper fraction is greater than 1 or less than -1, depending upon the sign. So that's what they have here. That's what they're talking about here. And they say it can equal 1 because 1 is included. The reciprocal of 1 is 1. So that's why we include the 1 and the -1, because they're their own reciprocals. And for secant, it's the same thing. So secant and cosecant. So if you were to write it in interval notation, for sine and cosine, it'd be from -1 to 1 with the brackets, because it's that interval and it includes everything in that interval, including the endpoints. For cosecant and secant, on the negative side, it comes up from -infinity and comes up to -1. It can equal -1, so we put the bracket. And then we have a gap, and then it starts again at 1 and goes to positive infinity, where it's closed at 1 and -1 because it can equal those values. That's why we use the bracket at those ends. And the U in the middle means the union of those two sets. So the Y value will either be in one set or the other set. Now, when you start putting numbers in for theta, and you take the tangent of it, then you just get all real numbers. The range of tangent and the range of cotangent is all real numbers. Even though there's numbers we cannot use in tangent and cotangent, the numbers we get are all real numbers. So the closer x gets to, the closer the angle gets to one of those angles you can't use, the larger the Y value gets, the larger the range number gets. So it goes towards infinity, either -infinity or positive to infinity, depending upon which side of that number you're on. You remember asymptotes from college algebra? So you have an asymptote here, and you have a number that, and then the graph goes up like that, and then the graph on the other side does the same thing. So that's a kind of a deal here we're talking about with tangent and cotangent, because it keeps going down and up forever. It just does it in several different places along the line, where we have a very restrictive, or we have a restrictive domain. There it is. Yeah. And here's an ISO chart for it. Oh, something I failed to mention. When they were talking about domains of the tangent and cosecant and secant and cosecant, I mean, and cotangent, they stated incorrectly, and I had corrected it for my PowerPoint, which means I need to create a new PDF for your PowerPoint slides, so it includes those corrected pages, those corrected slides. Now it says it correctly here, but it had it wrong in the PowerPoint. So now, next thing we're going to talk about periods. So here we're talking about, here I have an angle theta, and here I have another angle that goes around once and then ends up at where theta is. Okay. So if I, depending upon, it doesn't matter how many times I go around until I come to here, it's still going to be the angle theta. So this is a general formula for any angle plus 2k times k, where k is an integer number, positive or negative, then it's just the same as the sine of that of the original angle, or cosine of the original angle, because you always wind up at the same terminal side. So the 2 pi, we call that the period. Periodic function and fundamental period. Right. Fundamental period is usually the, we think about that as being the first period we think about, and it just repeats over and over again. All right. Function f is called periodic if there is a positive number p with a property that whenever theta is in the domain of f, so is theta plus p, and f of theta plus p equals f of theta. So p is called, and then there is a smallest such number p that this is true for. And so the smallest values is called the fundamental period of period of f, or we just call it the period. They put fundamental in the parentheses because we don't usually say fundamental. But we talk about the period of a function, of a trig function, and and then we talk about the fundamental period is like 2 pi is the period for sine and cosine. So 2 pi from 0 to 2 pi is the fundamental period, where 2 pi k is what is all of the angles. Okay. And so here are the periodic properties of the 6 trig functions. Sine and cosine, cosecant and secant all have the same period, and that period is 2 pi. So after you go out 2 pi units, all the numbers start repeating again. Hence the name periodic, because it keeps hitting the same numbers over and over and over again in a highly predictable way. Tangent and cotangent have a different period than sine, cosine, secant, and cosecant. It's only pi. So adding pi to 45 gives you the same, gives you the exact same tangent. Adding pi to 2 pi over 3 gives you the exact same tangent. So that means this point here and this point here, so this angle and this angle have the exact same tangent and cotangent. I mean, so this angle here and this angle here have the exact same tangent and cotangent. So going back to this. So this is how I look at it. I look at 17 pi over 4, and I want to take out 2 pi, a multiple of 2 pi. And so 2 pi is the same as 8 pi over 4 because I want the same denominator. And if I multiply this by 2, I get 16 pi over 4. And if I take, so this is like 2 times 2 pi. So I've gone 2 periods around. And so I'm going to take those 2 periods out of that. So that just leaves me pi over 4. So the sine of pi over 17 pi over 4 is the same as the sine of pi over 4, which is the square root of 2 over 2. So now we're going to look at the cosine of 5 pi. So 5 pi, I want to take out a multiple of 2 pi. Okay, well, 2 times 2 pi is 4 pi, so I can take 4 pi out of there. I want to take out the largest multiple that I can take out, and it still be positive. Okay, and so that just leaves me pi. So the cosine of 5 pi is the same thing as the cosine of pi. What is the cosine of pi? -1. All right, 5 pi over 4. Well, that's less than 2 pi, but it's more than 1 pi. So I'm going to subtract 1 pi, which is 4 pi over 4, which is pi over 4. So the tangent of 5 pi over 4 equals the tangent of pi over 4, which is 1. This one's in the first quadrant. This one's in the third quadrant. Tangent and tangent in the first quadrant and third quadrant have the exact same tangent. Angles in the first and third quadrant have the same tangent. So this was letter A. I'm going to finish this up and then we're done for the day. Yeah. Please be sure your name is in chat. I had someone last class who was very active in the discussions that we were having. He didn't sign it. So I knew he was there because we interacted, but yeah, he just signed in. And then yeah, so we get -1 there and +1 there. Okay. And then this is just what I'd covered earlier about where everything is positive and where everything is negative. So, and I already talked about that. So I'm gonna leave it at we're gonna leave it at here. So we're gonna end at slide number 87. Oh. So what I'm gonna do now is stop the share. You think? And okay. There's someone I need to talk to. All right. So I'll see y'all on Wednesday, unless you have questions for me. And I'm gonna post office hours soon. I've got them all squared away. I just need to post them.
Did you say Wednesday?
Oh, today's Tuesday, isn't it? So I'll see y'all on. Oh, yeah, today's Tuesday, right? I'm fine.
Yes,
Yeah, I'll
sir.
see you on Thursday.
Have a good one, Professor.
Yeah, I said that in my 8 o'clock class, and nobody corrected me. Okay.
You have a good
Oh,
day.
I have a question. Oh, sorry,
Yes.
you can go
Bye.
first.
Have a good day.
Thank you, Professor.
Okay. Who has a question?
Oh, I have a question.
Yes.
So for the first test is in 2 weeks, right?
Yeah.
And I was just wondering if it's gonna be over the first two homework assignments or
It's gonna be over whatever we get to the week before the exam.
okay. Got it.
Okay.
Bye, sir. Have a good day.
You too.
Wait, sorry, sir. I disconnected. What did you say about next Wednesday or Wednesday?
No, I was mistaken about what day of the week we're on. So I'll see y'all next Thursday, this Thursday.
Oh, okay.
And I said this Wednesday and someone questioned me on it and I realized I've been telling everybody the wrong day. So,
Okay. No problem.
okay.
All right. See you Thursday.
All right. Take care. Brian, Christopher, you guys got questions?
No, sir, no questions. Thank you so much.
Okay. Y'all take care.
Just listening around and see if I missed any questions.
Oh, okay. All right. Well, I'll see y'all later.
Alrighty.
Okay. All right. So now it's just you and I, and so you're having troubles with your computer?
Yes, sir. The version I have on my computer is not updated enough to get my math lab, but I'm seeing about getting a loaner or whatever update I need to do because I don't want to drop the class or nothing like that.
Okay. Contact the IT department, because sometimes they have
Mhm.
computers that you can borrow.
Mhm.
So you might contact them. I think I had posted that in that information in the email, and I think it might be in it might be in announcements. Let's see, the first announcement I put up. Welcome to pre-cab. Pre-cal. Yeah. Student support. Let me see what that is. Yeah, IT service. Yeah, you click, under welcome to pre-calculus in the announcements, you click the student support link.
Mhm.
It'll take you to campus resources and click IT services. And so you can get their phone number and call them. Okay. Or for the PAC IT is what, oh, there it is. PAC IT is here, let me,
I have it pulled up right now. The 210-84850-555 or
no, that's the
210-486.
colleges. I'd go with do the Palo Alto one.
Yes, sir. Yes, sir.
Because
Yes, sir.
that's what you want. Okay.
Okay. Yes, sir. I see it.
So they could help you or direct you to who does it.
And are the meetings recorded yet?
Say again?
Like are the meetings post like the meet? I know the meetings recorded, but are they posted to be
Yeah.
able to?
If you go back to the
send-
announcements, go into announcements, and where it says YouTube video channel for this class, there's a link there. It should take you right into it. So if you go ahead and
Okay,
click
I
that
see it.
now, and see what it pulls up for you. Because I want to be sure it works for you.
Yes, sir. It's pulling up, but it's loading. Oh, here you go. Oh yeah, it have
It
three.
should have 3 or
It have
4
all
videos
three.
in there already.
Yes, sir. It have 3.
And then a little bit later today, it should have today's in there.
Yes, sir. Yes, sir.
Okay. So if you're having any difficulties doing any of the work or anything, please let me know. Okay.
Yes, sir.
Because if I'd known this, I didn't known you were having difficulties getting into my lab, and it was a computer issue, I could have directed you to these people sooner. Okay.
Yes, sir.
So
Yes, sir.
don't be afraid to
Hopefully
let me know
everything-
what's going on. If it affects your ability to do work in the class, please let me know, and we can see what we can do to work around it. All right.
Yes, sir. Hopefully, we can get some stuff resolved today.
Okay.
Have a great one, sir.
You too. Take care.